Welcome viewers. In this video we are going to look design philosophy for transmission line towers. So in the right hand side you can see it is a multi-circuit transmission line tower having a 4 circuit, 12 number of conductors in 3 phases. Similar like in middle you can see in the top angle tower having some 15 to 30 degree or 30 to 60 degree deviations in conductor, and in the lower middle you can see there are some suspension tower which are having a I type insulator and V type of insulators. So let me go into detailed discussion. First of all, we need to understand the purpose of transmission lines. There are 3 major purposes. First one is power transmission. This will generate or whenever the electric energy is generated in some of the power plant, that power plant energy should be transmitted to nearest distribution lines. So it is a electric energy from one point to another in an electric power system. So you can see this picture. In this, from the power plant there is a step up substation which is transfer this electric energy to step down substation by high voltage transmission lines. From the step down substation, it is again through medium voltage transmission lines, it is supplied to distribution substation. From the distribution substation, it is supplied to utilities like residential or some small scale industries or to hospitals. So likewise distribution lines are to be required. So here you can see there are high voltage transmission lines, medium voltage transmission lines, and the distribution lines. So these are the things we can call it as power transmission lines. And also alternatively, there is from step down substation to some large factories, there is also some transmission line is required. And the next purpose is radio transmission purpose. It is to carry radio waves from the radio transmitter to the antenna. And the last one is telecom transmission. It is a communication between sender and receiver by electromagnetic systems. In this presentation we are going to look only the power transmission lines. So this is a radio and TV towers. And this is a telecom transmission towers or cell phone towers, we can call it as. So stages of transmission lines. There are 5 stages we need to go for transmission line towers. First stage is a transmission line survey. In that transmission line survey, the entire route of the transmission line to be identified by various method of survey. For example, analyzing the purpose using the obstacles, responsible factors, logistic routing. So this kind of information or input we need to do using this first stage survey. Aerial survey or Google GPS or total station and LiDAR survey are the techniques to be used for tower spotting. So once after the tower spotting is completed in stage 1, we have to move to stage 2. Stage 2 is nothing but it is a tower design. In this tower design we must have some 4 major parameters that we can call it as GLAD in short. In GLAD, the G stands for geometry, L stand for loading and load combinations, A stand for analysis and design, D stand for detailing. So these 4 parameters is very important while doing for tower design. So geometry means it is depends upon the spotting of the tower. What kind of tower is it? Either it is a tension tower or suspension tower or angle tower or dead end tower, that we have to identify. And the geometry, whether it is a vertical or horizontal configuration. So that configuration we need to identify, and finally the dimensions. So these three sub parameters will comes under geometry, and load and load combination we need to arrive as per the technical specification and the standard codes to be followed. Analysis and design we can do it in any 3D software such as STAD, robot structure, ETAP. So likewise there are very many softwares, or even manual design also we can do it as if it is preferred by the customer. And finally the detailing part is a very major important things we need to consider. So in this detailing part we need to provide the entire drawing and the scheme format. So this we can have some three major steps to be done, like one is assembly drawing, another one is GA drawing, and another one is shop floor drawings. So these kind of three stages of drawing we need to give under the D, which is a fourth factor in transmission design, like GLAD, GLAD. Next, after completing this tower design, we need to go for the stage 3, which is a tower fabrication and proto testing. So this generally used to done in fabricator factory itself, or sometimes it will have done in project site. This proto testing used to happen. So for that, what the proto testing means, that the entire similar model can be generated at a real-time fabrication system, and the actual load which are tested, which are going to applied in this problem, this way we can call it as a probabilistic method. So in that testing they are going to apply the actual load which is going to apply on the transmission line tower when it come for erection. So those things to be comes under stage 3. In stage 4, transmission line construction work, this including both the erection of a tower and the construction of foundation below the tower. Stage 5 is a as-built drawings. This is like the preparation after line commissioning. Once after completing all the commissioning activities of the transmission line tower, there may be some changes which are occurred as per the site conditions, so that information we have to capture in as-built drawings. So these are the 5 major stages in transmission lines. So when coming to the design philosophies of transmission line towers, there are 4 major things we need to consider. One is a responsible factor. This is a right to way availability. Suppose the transmission line tower is located in a land area where access to the landowner and to the utility of the lifelong the period of the transmission line tower should be documented, so that there should not be any right to way issues in future. So this should be considered as a responsible factor. Next one is audible noise level. So you can hear in the background there is a hissing noise. So this is generally if you are going to stand in between any transmission line tower which is having more than 500 kV. In that we used to hear some hissing sound. It is like the iron, the electronic iron is going to pass through this conductor, whereas air insulation is happening in the face-to-face distance area. So while there is a charge particle is moving in the conductor, this kind of hissing noise we can able to feel while we are standing in the transmission line tower. Generally there is some regulation is there to be followed. This should be less than 55 decibel. Similar like for radio and TV interference also we need to check. That is also for in order to avoid the interference, this transmission line should have less than 50 decibel. Likewise, electrostatic field aspects like ground clearance, face-to-face clearance. So these all responsible factor we need to consider while going for transmission line tower. That is for power distribution purpose. So for that, in order to reduce this noise level and the TV interference, radio and TV interference, we can also provide a corona. You can see here it is a corona, which is a circular member used to provide to resist or to reduce audible noise level. Next one is design related concept. So there are 3 concept are there. One is reliability, in that service of the entire transmission line tower, which is to be capable over the life the period. Actually, it is the performance under various set of conditions, like environmental conditions, whether this transmission line tower is capable to withstand the wind, snow, ice, temperature variations. So these kind of environmental the performance conditions we need to analyze. So for that we can call it as reliability. Second one is security. When there is a broken wire conditions, whether the structure is capable to withstand sudden accidental happenings. So that kind of studies we need to do in security analysis. And finally, the safety concept. In that safety concept, both normal and broken wire condition to be considered for temperature and no wind conditions. Both security and safety we need to consider no wind conditions. So this is the problematic state of concept we need to consider. And the third one is a design approach. There are various design approach we used to have it. Number one is probabilistic state. In this dynamic research method to be analysis, like after this testing, this kind of after the testing, the behavior of a structure to be recorded, and that same understanding, that lesson learned to be incorporated and the redesign to be done. So likewise, so that way of doing the research based upon the problem which is occurred is called this probabilistic state. Next one is limit state. It is optimistic methods which generally we used to do in many of the structures. Ultimate state is the extreme capabilities method. Serviceability state is a working state method, which we can call it as over design, because in that factor we used to consider more than 1.5 for all the load cases. So that is generally not required. Next one is standards. This is a main thing, because many of the standard code, there are exclusions of overhead line transmission line towers are available, so that we should follow only that exclusions of codes. Say for example, in American standard there are ASC 07 2010 is a main code for load calculation for wind, seismic, but in case of a transmission line tower we should follow only ASC 113 or ASC 52 manual. Similar, like in Indian standard, instead of following ISC 875 for load combinations, we need to follow ISC 802 also for load calculation. Instead of ISC 875 part 1, 2, 3, 4, we need to follow ISC 802. Similar, like for European standard, instead of following EN 1991 and 1990 for load and load combination, we need to follow 50341 part 1 and its national annexures. And next one is the functional type of transmission line towers. So there are few types in functional aspects for transmission line towers. So one is the suspension tower. In this, conductor to be connected in suspension insulators, because that suspension insulator are vertical in direction parallel to the conductor fixing as a perpendicular to conductor span, so that tower arm bottom is to be hold that suspended vertical insulator. In this case, conductor connection will be done below suspension insulator, conductor spanning both sides. So the next one is a tension tower. In this tension tower, the insulator direction is in horizontal, so that it's a required dropper also to connect for two spanning conductor spanning both sides. Angle tower is another type of tension tower. Even the angle tower also having several variant. One is from 5 to 15 degree of conductor angle deviation. Another one is 15 to 30 degree, and the third one is 30 to 60 degree. So these are the variant of angle tower under tension tower. And the next tension tower is a type of tension tower is a dead end tower to be used in starting and terminal of transmission lines, that is nearest to the substation, or tension will be in one side. So this is a photo view of suspension transmission line tower. You can see both the directional conductors are fixed to the bottom of vertical insulator. So this is tension transmission line towers. So here you can see that tension insulators are used in both the side fixing, and the dropper which is connecting here in the right hand side, you can see both the side conductor are connected using dropper. Sometimes there are also some insulator to be placed, vertical insulator to be placed here. This is a view of angle tower under tension tower. So here you can see this, both the one side and other side of conductor is having various angle. This angle may be more than 30 degree. It should not go beyond 60 degree. Sometimes this also to be installed with the vertical insulator to connect a jumper or dropper. So this is a view of a dead end tower. In this you can see the conductor is in only one side, other side it is tapped off from the cable ceiling end and going into the substation side. So there are some cable ceiling end are fixed here, and surge arresters also there. So from there, using the cable, it is going to be distributed to substation or any industrial requirement. So these are the four we had seen. Addition to that, there are other functional types of there. One is the transposition towers. In these transposition towers, the face-to-face conductors in three sections are in separate direction. It won't be in same direction, whereas it will fixed in a rotation basis. The face by rotation occupies each position in a circuit. So we will see that. And special towers. This is a location of long span river and valley crossings, creek crossings, power line crossings, etc. falling on the route line. So whenever there is a huge crossings, say for example in range of more than kilometers, the special towers to be designed there. Similar like the offshore towers, whereas the gust wind and exposure to salinity to be considered, the special kind of tower we can call it as offshore towers. And fascinated towers are nothing but it is a resemblance of something real lives, like for example a humanoid, a reindeer or any beast kind of fascinated view. This kind of towers we can call it as fascinated towers. So you can see the transposition type of tower. Here you can see when you consider this R1, that is a red color face, this is now connected this side in middle arm, top arm. With the dropper it is going down and connected to middle arm and going out to the other side in the middle arm. So this R1 itself connected in middle top arm and going out through middle arm. So likewise, if you consider this white to yellow line, it is connected in lower arm, middle arm, and it is going out to other side in lower arm using dropper and the tension and suspension insulators. So this is like a zigzag, that rotational basis this face of conductor will moving. So you can see the other view, elevation view, whereas red and yellow are having in a same, which are connected in both top and middle cross arm, and the blue line is connected in top and lower arm. So this is called transposition towers, and this is a special tower. Actually it is in this tower is in the proposal. This is to be constructed in China. It is a 500 kV line. The tower height is 385 meter tall, having a 75 meter base. This is spanning, the conductor is spanning 2.5 kilometer, crossing width of river 2 kilometer. This is to be planned commissioning for the year 2023. So this kind of special towers also available. This is a view of offshore towers, whereas we need to consider the gust wind and the terrain. Wind terrain is very difficult to consider, because that there is no obstacles here, so that there will be a possible of a dynamic wind, the pulsated wind, so that to be considered, and the salinity of the air moisture also to be considered while going to design of transmission line tower in offshore. So this is a humanoid, or we can call it as fascinated towers. This is still in the proposal from 2008 in in Iceland. This is awaiting for approval to be constructed in Iceland. Still from 2008 it is not in a approval stage. This is in a clown shape. This tower is already executed in Hungary. Also some special fascinated towers like reindeer shapes are which are still in the proposal that may be executed. Next one is we are going to look the type of transmission line in constructional aspects. There are two major constructional types of transmission line towers. One is self-supporting towers. Here you can see from the left side it is a single circuit, whereas the two faces are connected in one arm and one face is connected in top arm. So similar like in the second one is, it is also a single circuit, whereas every face of conductor is connected in each arm, top, middle and bottom. So in the third one is a double circuit, and fourth one is a multi-circuit, 4 circuit. And these are the guide towers. Guide towers is nothing but this will occupy more space, because that right of way is required more space in this, because that guide will span more than 10 meter. It will occupy more than a 10 meter area surrounding of each tower, but it will depends upon the height of the tower. So these two structures, pillars, used to support laterally by using guide wires. So even that guide tower also, there are two type of subdivisions. One is a conventional type. So this the view which you are seeing, the three images are the conventional guide towers. This is the second subdivision, chained guide towers. So in this, the conductor will run inside the two verticals, two main members, that is structural members, and these two structural members are connected or tied with guide rope and founded on the ground. Next we are going to see tower geometry. So based upon the colors, you can see the right hand side pictures. The top one is a peak that is in a brown color, topmost part of the tower which is holding the wire, ground wire. Next one is in blue color, cross arm. This is to be hold a ground wire with respect to insulators and hardware. So these three are the cross arm here. And the next one in green color is a gauge. It is a portion between peak and the tower body. The fourth one is a tower body. Here you can see in the bottom of the right hand side picture. It is to be a parts connecting gauge and boom to foundation or extension body or legs. So we will see what is this body and the leg extension and the boom in the next line. Body extension is nothing but, suppose this tower is located in the lower level. You can see here there are some gap in the level, gap in the area where this tower should be laid over this ground. Also the other tower you can see which is located exactly on the ground. So we need to match this tower height using a frame called body extension. So this is called body extension. So whenever there is a level difference between the two towers, nearby two towers, to match the level of this conductor fixing, we used to provide a frame at the bottom of the designed or fabricated tower. So that part we can call it as body extension. Next one is leg extension. So this body extension means we are going to extend all the four legs. But in case of leg extension, it may be extend to any one of legs or any three or any two, according to the variation in foundation levels. This is applicable mainly for hills and valleys. So you can see in the right hand side picture. So suppose my transmission line tower is located like this, whereas the ground for one, that is a right side leg, is having at the higher level, higher ground level, and the third one and the left side leg is at a higher level, whereas there is some gap to be filled. So for that leg extension to be provided only for the leg which is to be matched to the ground. So this brown color frame is called leg extension. Next one is boom. This boom structural frame is mainly applicable for horizontal configuration tower, which is to be attached to lower body to hold conductors. So this picture you can see, this is a boom in blue color where the three phase conductors used to connected in horizontal way, red, yellow and blue. But in this right hand side picture you can see the only conductor used to fix in vertical direction, red, yellow and blue. So this horizontal configuration only we used to have boom structural frames. So these are the structural part are identified here. Next one is tower dimensions. So this tower dimension is very important while we are doing for tower design. As we said earlier, there are four stages to be considered for tower design: GLAD, geometry, load, analysis and design and detailing. So for GLAD, that is geometry condition, we need these are the input: minimum ground clearance, maximum sag including creep, length of suspension insulator, vertical spacing between conductors, location of ground wire, angle of shield, minimum midspan clearance, tension insulator drop. So these are comes under tower height finalization. So for tower width, in order to decide the tower width, we need these three important things. That is, at the ground level, that is a peak base of the tower, how much we can extend. So this we need to check as per the right of way. So how much extend the land is available to occupy for a transmission line tower design. So that we need to identify while finalizing the tower width. And the next one is the waist level. It is a connecting of gauge and the body. How much, because based upon the cross arm, this waist level will vary. And the next one is cross arm or boom level. So this location, from which area, which height this to be fixed, and how long this should be expanded. Like face to face distance is a major role to be played on this tower width. And the next one is cross arm span. In this type of insulator, suspension insulator, tension insulator, I or V string. So these parameters we need to consider while fixing these dimensions. Angle of swing, what kind of angle is either it is 0 to 5 degree or 5 to 15 or 15 to 30 degree or 30 to 60 degree. The angle of deviation of the tower, nearby tower or the conductor to be checked to finalize the cross arm dimensions. And finally the face to face distance between the conductors, which are required for finalizing the cross arm dimensions. So these are the three configuration which we are going to see, the basic input about the dimensions. So here W from the bottom you can see is a base width of the tower. A represent the body height. B is a gauge height, that is from gauge height between, or we can call it as center to center distance of face of the conductors. And C is the peak height, that is face to ground wire, conductor to ground wire distance. And H is the total height. In the left hand side you can see single circuit tower, vertical barrel. This one is a double circuit vertical barrel type. And the third one, or the right hand side picture, is a single circuit horizontal boom. So it is having the boom. As we already discussed that as the conductor R, Y, B, red and blue are connected in vertical direction, we can call it as vertical or barrel type. And this case, in the right hand picture you can see the conductor are connected in horizontal, so we are calling as horizontal. So we will see the dimension based upon this tower picture. So this is a tower dimensions basically we need to consider for going for the design. These dimensions are tentative and subject to a project requirement. So here you can see in the first column voltage are listed from 45 to 1200 kV, and various configuration. As we had seen just before, there are three pictures: a single circuit, double circuit vertical configuration, and a single circuit horizontal configuration. So these three configuration are listed based upon the voltage level. And ground clearance, that is from base of the tower to the first lower cross arm, that is lower conductor, we can call it as ground clearance. Face to face distance is from one conductor to another conductor, how much distance we need to maintain. So it is applicable for both left and vertical and horizontal configuration. So likewise face to earth also provided here. And tower height, total height from base to top. Base width, so you can see this 1200 kV, it is required at least 19 meter of base width. So you can assume how much thing we need to consider for the responsible factor for right to way. Likewise in 800 kV also it is having 18 meter or 51 feet. But for 45 kV you can see 4 meter is base width or 13 feet. So total height it will come around 10 meter. So likewise this table are listed here, but this is a tentative one according to the project location and the terrain category and the survey or the tower locations. This will vary. If it is located in nearby river, then at least we need to provide 15 meter from 15 meter up to the base of the tower. It should be increased. So likewise we have to decide the dimensions. These are the preliminary input required for transmission line tower design: survey map, which we already discussed, electromechanical principle drawings, structural details like tower height, body cage, cross arm span. So those are things. And the conductor and earthware details. There are 4 major type of conductors. AAC is all aluminum conductors. All aluminum alloy conductors is triple AC, and aluminum conductors steel reinforcement is ACSR. Aluminum conductors alloy reinforced is ACAR. Generally that ACSR is most popular. So in that we need to know the sizes, span, weights, wire tension forces, all those information we record to calculate the conductor load applications on the transmission line tower. Hardware details are suspension, tension insulator, V insulator, dropper, jumper, weight and sizes are required to calculate wind load and self-weight of the materials. Environmental design loads like wind, snow, temperature, generally seismic can be ignored in most of the practice. Standard loadings to be followed and design material like ANSI, Eurocode, SNP, BS, BIS. So that thing is important for important as input for design and engineering. Supplier catalog for available profile or sections. Design procedure are comprises of primary loads, load combinations like technical specification and standard code, modeling in 3D analysis software, applying loads and 3D modelers, applying load combination 3D model, run the analysis, slenderness check to be done using that standard code of practice. Generally it is 1.2 times height divided by I. I is a radius of gyration. Slenderness limits are 1200 for main leg and the cross arm lower members. For all bracing members it should be 200. Redundant or nominal stress carrying members we can consider as 250. Tension members it is 400. So likewise slenderness check to be done. Most of the member sizing can be completed if we are doing the slenderness check properly. Next one is the design of structural members. This we can do it in 3D software itself, or else manual calculation we can do it. Deflection check we need to do it. Generally this AAC 113 used to give the deflection limit as height divided by 100. So that we need to check from the 3D software output or manual calculation output. Next one is a design of connections like splice connections on leg members where there is a splice is required in between every 6 meter or 12 meter of material available. And bracing member connections, in this we need to check bearing, tension and shear. Base plate connections, tension and compression. Next one is we need to extract the support reactions for foundation design. And finally the design of foundation bolts and stub connections and the foundation design. So these are the general procedure for transmission line tower design. Next one is the software and the tools to be used for transmission line towers. For design and analysis, power line system, PLS, CAD, ETAP, MS Tower, StatPro, robot structural analysis can be used. For detailing and modeling, AutoCAD, Advanced Steel, BowCAD, Navis Work, Tekla structures can be used. Addition to that, there are some other softwares also there that may not be listed here. Hope this presentation found interesting and helpful for you. We will see in another video more technical with power transmission line tower. Thank you for watching. Look description for more related video. Subscribe to this channel for more updates. Thank you.